We use technology for good. We use it to innovate, improve, and empower, to create better working conditions, to make people safer, healthier, and happier, to save companies time and money, and to help them become more successful. To do this, we keep researching, designing, and developing. We keep looking for ways to make technology extraordinary, to turn possibility into reality and potential into practical, to embrace the new industrial revolution and to move us all forward. We do this constantly and endlessly, as we have for 20 years. We believe in the future, and we create the future of work now.
The big challenge was just bridging that gap between the equations, the theory, the big abstraction of something like the Laplace domain, to how something is actually practically controlled and what the physical thing is that's enacting a change that will affect the processes, and the in-between, the simulation. How can we create a little sandbox where we can play in? So in our practical, we touched a little bit of the real things in the universe, and then we had a little bit of simulation, and then we had this abstraction, but they were very disconnected. And I could see that in students. They were kind of just rote learning the answers to the Laplace domain, and the way that they engaged with the practical, there just wasn't a nice golden thread running through everything. So that was some of the challenges that I was seeing. Like, there's just this disconnect between what happens in a little mixing vessel and what happens in frequency response in the Laplace domain. One of the big interventions I made is to just in the scheduling of the classes. You normally have 3 theory lessons and then per week, and then you've got a TAT in the afternoons, and you've got a practical once a semester, and now and then an assignment. So I wanted to really use that simulation aspect and bring that to the forefront, not only as a standalone during tutorials or a standalone during assignments, but to use it as a tool that's part of the lecture. So there's not that disconnect between this is what we talk about and this is what we get asked. So one of the changes I made is to just request a computer venue, so that one of our 3 lectures became hands-on examples, and I called them my HOEs. So students knew, luckily it was on the same day as the tutorial, luckily. In the morning we would have our hands-on example class, and then in the afternoon we had the TAT, and they were in front of the computer and they had little simulations. So the simulations were there even from week 1. Simulations were typically kind of just relegated to this 1 week during the whole process control course, but here it was from week 1, and that giving them like little sandboxes to play with, and giving them the little systems that explode and the control that goes up and down, and then kind of adding the whole time to the simple examples that we were doing, and also building an assignment, breaking the big assignment up into 5 pieces and continually using the same sandbox, and just kind of adding layers and layers to that, and referring to that the whole time to the theory. So I think that helped, but it brought its own challenges as well. Just introducing a tool that you use as a sandbox introduces a new set of knowledge and a new set of skills. So you kind of do have to take something away as well. So it was interesting that some of the students managed to kind of rote learn the tool, but not necessarily understand the bigger context. But I think, it's fine. I think that it introduced new complexity, but I think it was a net positive effect in the end, just to be able to have something to play with, to understand control is not just some dry frequency domain equations, but there's stuff that moves up and down. engineering faculty, Stellenbosch, did have lots of too much to keep track of initiatives and resources. I mean, the Finlo projects, and our department head would like motivate us to take part, and there would be these faculty teaching and learning things and the Prontact courses. So there was this whole world of resources. And then there was your individual tinkering. And at some point, you go and listen to people's talks at faculty meetings. You're like, okay, cool. I would also like to, tap into that. You would see some cool stuff that people were doing. And there was an initiative on blended learning. Oh, I can't even remember when last it was. But I thought, okay, well, this is nice. This is kind of blended learning in the sense of developing a little bit, giving a little bit more emphasis on the students' participation. And I think one of the things that I signed up for a blended learning project, and that was still to develop like little videos and little interactive online tutorials, and also use some of that for student assistance to help develop these simulations. And I think that kind of opened my eyes to, collaborating with people that's got more experience and that, kind of do it as a day job, like you, for example. And that, I think, was kind of the entry into the space, was to see what other engineering lecturers were doing, what kind of projects that they do. That was a big inspiration. And also just to get the people that had the theory of education, that kind of had that already, then to start working together. I think that was very useful. And the nice thing for me was that to find like-minded people that care so much about, education, that kind of their teaching component isn't just kind of something they have to get through before they get on to the next research topic. So that was very nice to have this community of people that has the same kind of heart and passion for it, and are trying to find tools and kind of this multiplicative value. We're not all trying to reinvent the wheel. And it was also nice to discover that there's a whole kind of science and practice and theory behind it. So those were all very nice things. Now in my role, I'm doing some training as well. So there's this like data analytics for process engineers course that I've given 4 times now, 3 times, 3 different cohorts. Over the last 2 years externally for a mining company, and then once also for Stone 3 internally. So that's kind of my new engineering education context. There's a couple of interesting articles on educational reflection of how should we teach data science for undergraduate curriculums that I've found, which might be of interest as well. So I've looked at, so I think that's my extent of looking at how people are talking about data science education, as looking at articles describing how it's, and that's been very useful to me. You still keep a notebook. So I think one of the big things that reflective practice has kind of brought me is a deep breath in, and a kind of sense of peace of mind to know that it's a marathon and it's not a sprint. Because I know that, as a critical person, as a, perfectionist, whatever, you want to have this wonderful product, but it's exhausting. And if you throw yourself in trying to make the perfect thing the first time around, you might be so gutful of it after you're finished that you don't actually want to look back. So I think in my reflective practice, it's much more about, okay, this is marathon. Don't exhaust myself so much that I don't want to look back. So I have this I have this vision 1, vision 2, vision 3, a continuous improvement, and that's okay. Everything that I'm doing to improve is on the bigger path of it. And I think also to just keep chatting to the people that I'm training to get their feedback and find out what the experiences of it is. I don't think I'm organized enough to have this 115 item list of ways to improve, but I keep my notes, and I have peace of mind that it's a marathon, it's not a sprint. So as long as I keep the 3-4 main things that I want to improve in the next iteration in mind, I know you can only go up.